Looking at part 11 on page 12 here, again, you should have thought about the warm-up, read through the why for today, okay? And targets for today, correctly writing ionic formulas, which you will learn are just metals and nonmetals. You also need to name them, okay? So not only can you write the formula, you can name it. So we're going to start off by defining what ionic bonds are, okay? Because we're going to be focused on naming ionic compounds today, okay? So we need to think about that word ionic. I know you've heard it in other classes, other science classes, so we're just going to touch on the basics here and not get into them as much in depth, but ionic bonds are the ones that we're donating some electrons between different elements that are involved. But most importantly, ionic bonds are made up of a metal plus a nonmetal. And you should know from looking at your notes from an earlier lesson here, okay, that you should be able to decide if things are metal or nonmetal. Okay, now if you're like, I don't remember that already, right, you want to think about looking back at your notes to try to figure that out. So if you look at part 9, and we're only on part 11 now, part 9 dealt with how you decide if it's a metal or non-metal. So you're looking at those steps on the right side of your periodic table. You need something on either side. Metals are on the left, non-metals are on the right. But examples would be if sodium and chlorine come together, magnesium and fluorine come together, aluminum and oxygen come together. Each one of these examples has one on the left of the steps, one on the right of the steps. Okay? Now, how do we write their formulas? And we're going to talk about this all year long. Okay? You need to write their symbols. Okay? So you write the metal, then the non-metal. So if we're doing sodium and sulfur, for example, metal first, so sodium is Na, sulfur, non-metal, is S. You write the charges, so you look back at your periodic table, okay, so sodium is in this first column, so it's +1, sulfur is in this column, so it's -2, so all we did is write +1 next to sodium, -2 is sulfur, okay? So again, I wrote sodium as +1 since it's the first column, sulfur is -2 from its column. Then you're going to do what we're going to refer to as crisscrossing the charges, okay? So the 1 goes down after the S, and the 2 comes down after the Na. Notice I didn't say positive or negative because it doesn't really make sense to bring down -2. What that 2 means is there's 2 sodiums. -2 sodiums doesn't make a lot of sense, so we just ignore that negative sign, okay? So when that 2 comes down, it looks like this, okay? And the S has a 1 after it, but the 1 is just implied. You don't need to write it. So what this means is there are 2 sodiums and 1 sulfur. Now you need to make sure that you're practicing writing the symbols or the numbers as little subscripts next to it. Okay, so notice how that 2 is much smaller than the Na. Okay, now make sure it's written out that it's reduced. Okay, so this one is, we're done. Na2S1. Okay, you could just say Na2S to make life easier. We assume you mean S1. But here's an example where it's not reduced, so you know what I mean. Okay. Magnesium and oxygen forms Mg2O2. You see how both of these are 2's, and that's kind of excessive to say. So we just cancel out those 2's together because they're just going to reduce down, and it becomes MgO. Okay? Now we're going to get into a bunch of practice with this, right? So you're going to have to take some time to really work through this to make sure that it makes sense to you, right? And that's what that practice is going to be for. So we're going to do this together right now, and then you're going to practice writing the formulas, like the actual names too, so that you can do both ways. So first one, sodium and nitrogen, okay? Well, we just looked at sodium up here. Fountain's going to be a little easier to stop about it. So I'm going to write sodium is Na, nitrogen is N, okay? Sodium, if you go back to your periodic table, is in the +1 column. N is nitrogen is -3, okay? So Na is +1, nitrogen is -3, okay? Then what I'm going to show with these arrows is that I'm going to crisscross them. Okay, so the 1's going to come down after the N, the 3 is going to come down from the Na. So it's going to look like this, Na3N. Again, there's a 1 here, you don't have to write it, okay? I won't write it because it just is assumed that there's 1. If there were 0 of them, it wouldn't be there, okay? So Na with the smaller 3 next to it, and then N, because that 3 came from the nitrogen. I checked to make sure I can't reduce. It's a 3 and a 1. I can't reduce, we're done. If it was a 3 and a 3, that'd be a different story, okay? Next one, magnesium and phosphorus. So this will take you some time, but I know that magnesium is Mg, phosphorus is P. Okay? You can look at your periodic table to find that, but here's magnesium. Okay? Phosphorus is over here. Magnesium is in the +2 column. Phosphorus is in the -3 column with nitrogen. Okay? So +2, -3. So I start with writing the charges up top as like powers almost, and then they're going to come down as little numbers, subscripts next to it, okay? So show that crisscrossing, not exchanging. So I have Mg3P2. Okay? The 2 from the Mg comes down after the P. The 3 from the P comes down after the Mg. Okay? Mg3P2. And that's it. Okay? Because it's a 3 and a 2, I can't reduce it down. Right? Next one's aluminum and selenium. Okay? So aluminum and selenium, as you look on your periodic table here, okay? Aluminum's over here, selenium's here. Okay? So Al and Sc, if you didn't know that, again, you'll learn. Al and Sc. So Al is in the column, that's +3 here, okay? Sc is in the -2 column, so I'm going to write that. +3 and -2. Show my arrows to crisscross. So I get Al2, Se3, okay? The 2 from the Sc comes down here. Al has a 3, which comes down here. I check them, 2 and a 3, can't be reduced, we're done, okay? Cesium and nitrogen, okay? So it's the last example, we're going to practice the formula writing. So cesium is Cs plus 1. And then the next one is nitrogen, which we did before, N minus 3. Okay? So I'm going to write cesium, Cs plus 1, nitrogen minus 3, crisscross, show my arrows, Cs3, N. A 3 and a 1, so I'm done. Okay? So that's all there is to formula writing. Okay? So you start by writing out the symbols and the charges with them. Show your arrows to crisscross them to the other element, and then make sure you can't reduce it down, which we can. Okay? Now let's talk about naming them. You don't just call a compound like cesium and nitrogen. It's not a good name for it. Okay? So to name them, the first thing that we're going to want to naming formulas for ionic compounds. The first step, you want to make sure it's a metal and a non-metal. The only reason I say that is we're going to get into compounds that aren't. So one on either side of the steps. Then you got to name the metal what it's normally called. The second element, which is your non-metal, just gets the IDE like we practiced with the anions. So you're getting a little used to that, okay, from part 10. Then what you're going to do is just name it. So element, the first one normal, second one IDE. So instead of sodium and chlorine, it's sodium chloride now. Now, here's kind of a weird exception. We talk about those transition metals in the middle of the periodic table. Notice in part 9 we didn't number them at all, and I even said that they could have more than one charge. Since they can have more than one charge, we need to use Roman numerals. If you remember those, I know they're not used as much. But to tell someone what the charge is, okay, because they can have more than one charge. All right, and we're going to practice that, and you'll see 2 examples down here, and we'll give it a try down here as well. Okay? So, MgBr, magnesium, this gets an IDE, so bromide, magnesium bromide. Aluminum, named normally, sulfur becomes sulfide. Calcium, named normally, nitrogen becomes nitride. Strontium, named normally, P becomes phosphide. Copper, okay, is named normally because it's the first part. S instead of sulfur becomes sulfide, but we have a Roman numeral here. The reason for that is copper is in the middle of the periodic table, okay, and we can check. So copper's right here in the middle, okay, so these middle ones that don't have numbers above them, 3 to 12 here. So column 3 to column 12, right here, okay? So we need to tell someone what its charge is because it could have more than one charge, okay? Now, how do you do that? Well, we know S is -2, so you use that part to help you. So if S was -2, that means copper has to be +2 to balance it out. Think about it would have been Cu2S2 first, so it would have reduced down to Cus, okay? Next one, nickel chloride, okay? So again, nickel's in the middle area here, so we need to tell someone what its charge is with the Roman numeral. Chlorine is -1, okay, which is right here. So we know that nickel had to be +1 to balance that out, okay? So that's why nickel, parentheses, 1 Roman numeral, chloride, okay? Now let's practice naming them. All right, so that first one there, magnesium and phosphorus come together, okay? Now it's written how it should be using the crisscrossing that we just practiced, okay? So I'm just going to type this just so it goes a little faster here. So we're going to have magnesium, new one. Okay, so we've got magnesium, and then instead of phosphorus, it's going to become phosphide, so IDE ending, changing there, okay? So that's the first one. The next one, lithium and bromine come together. Okay, so we're going to go ahead and call that one lithium normally, and the bromine is going to change to bromide. Okay. So lithium bromide for that one. That's the second one there. I'll make this one a little smaller so we can see that. Okay. So lithium bromide is the second one. This next one's interesting. Right away I see copper, okay, which is in that middle part of the periodic table, okay? So we're starting to think, okay, I need a Roman numeral there because it's in the middle of the periodic table, only for those ones in the middle, okay? But I know it's called copper. I'm going to put parentheses to remind myself I need something there. I'm going to come back to it. Selenium becomes selenide. You undo the crisscrossing. So the 2 came from selenium, so that means the 3 came from the copper. So this is going to get Roman numeral 3, okay? So copper 3 selenide is what we're looking at for that one, okay? Next one, we've got aluminum and oxygen. That was named pretty normally. Aluminum's not in the middle of the periodic table, so no need to worry about a Roman numeral. Aluminum oxide, okay? Make that one a little bit smaller too, so we can get that one lined up. Okay, the next one would be pretty similar. That one out. It's just calcium oxide instead of aluminum. We just changed it to calcium oxide. Down here, so we've got K2S. What's K called? K is potassium. Is it in the middle of the periodic table? No. So since it's not, I don't need a Roman numeral. S instead of sulfur, sulfide. Okay. And the last one here, we've got TiF3. So if you're not sure where Ti is, it is also a transition metal in the middle of the periodic table. Okay. It's called titanium. I know you've heard of it before. I'm going to put parentheses to remind myself I need a Roman numeral there in the middle because titanium is in the middle of the periodic table and can have more than one charge. If you're not sure, it's right here. Okay. So I'm thinking I need to use a Roman numeral here. I don't know what it is quite yet. That's fine. Fluorine becomes fluoride. And then I undo the crisscross. So the 3 came from titanium here, and then fluorine had a -1 charge, so there's no 1 there. But I undo the 3, which means that 3 came from titanium. Okay? So titanium 3 fluoride is the name of that one. Okay? So what you need to do next is you need to really practice this. So name them, write the formulas, check your answers. I posted the answers there, and then I do need you to do a mastery to make sure you understand. Remember, you only need these Roman numerals if it is the transition metal in the middle of the periodic table. Okay? If you don't see any Roman numerals in here, just follow what we normally did. Write out the charges and crisscross them.